section 8.2, Law of Cosines. Final section that I'm going to cover on this is we're going to bring in another formula that we can use to find the area of a triangle. If you remember, we know the area of a triangle is equal to 1/2 base times the height. I don't know why I keep wanting to put a capital H for that. So base times the height. And that's our standard triangle formula if we know the base and the height of the triangle. We then said, well, if we use methods similar to law of sines, that we could say A is equal to 1/2 B times C sine A. And we could do any modification of that, so A times B sine C, A times C sine B, right? So there were three possibilities with that. So that was another method that we could use if we had two sides and the angle in between those two sides. So side, angle, side. And we also said that we could, if we can get to the state where we have two sides and the angle in between them, then we could find the area. Well, now what I'm going to talk about is Heron's area formula. So Heron was a Greek mathematician, sorry, went on screen for a second there. He was a Greek mathematician, and he came up with this formula. Now, we're not going to do the derivation of this. I did that for the law of sines, I did that for the law of cosines, and such. I did it for finding this. I'm not going to do it for Heron's formula because if you look it up in a textbook, you'll see that's a 3-page proof to get to his formula. So we are just going to leave it at that. If you really want to see it, you can look it up on YouTube. There are people who explain it. You can look it up on Google, and you can see what this proof is. I am just not going to go through it because I don't have enough board space, and I'd have to keep writing on, erase it, and write again. So what we do need to know is how to find the semi-perimeter . The semi-perimeter, which we use S to define, is half of the perimeter of a triangle. So that's 1/2 A plus B plus C. The perimeter of a triangle is the sum of all the sides. The semi-perimeter is half of that. Just like a semicircle is half a circle. A semester is half a year. More or less. It's a two-semester school year, so it's half of the school year. So that's the semi-perimeter. Now, with Heron's formula, he uses the semi-perimeter and he says the area of a triangle is equal to the square root of the semi-perimeter times the semi-perimeter minus the first side times the semi-perimeter minus the second side times the semi-perimeter minus the third side. So it says we're going to multiply all of those together and then take the square root of it, and that's going to give us the area. Well, if you look at this, that kind of makes sense. We have a length. We have a difference in length, so a length. We have a length, and we have a length. So we have 4 lengths, which means we've got to whatever the unit is to the 4th. We take the square root of that, and that's going to take us to the squared, which is what area turns out to be. So this is going to be our equation. It's not that difficult an equation to remember. It's just the square root of the semi-perimeter and then multiplied by the difference between the semi-perimeter and the length of each side. So it's the semi-perimeter. What's half of the perimeter of the triangle? And then half of the perimeter minus a side, half the perimeter minus another side, half the perimeter minus another side. And that's going to give us an equation. So I'm going to move this over to the side here. A is equal to the square root of s times s minus a times s minus b times s minus c. And the beautiful thing of this is now, if we have three sides of a triangle, the lengths of the three sides, we can find the area and we don't even need the height. We don't need any angles. Right here we needed the height. We don't need the height. We just need the length of the three sides. Here we needed one of the angles. We don't need the angle, any angles. We just need the lengths of the three sides. So let's start with a triangle with certain length sides and find the area. So if I have side A is equal to 11.2 feet, side B is equal to 8.7 feet, and side C is equal to 7.1 feet, and I want to find the area, we can use Heron's formula to do this. Now, first of all, we want to check and make sure that it really is a triangle. So we add up the two smaller sides and get 15.8, and yes, that is larger than 11.2, so we do have a triangle. So we need to find the semi-perimeter. That's 1/2 of the perimeter, the sum of these. So 11.2 plus 8.7 plus 7.1. So S is equal to 1/2 of 11.2 plus 8.7 gives us 19.9 plus 7.1, so 27. And 1/2 of that is 13.5. So the semi-perimeter is 13.5 feet. So that's our start. Now that we have that, we can find each of these. So A is equal to the square root of 13.5, 13.5 minus A, 13.5 minus 11, we'll put that in there, 13.5 minus 11.2, 13.5 minus 8.7, and 13.5 minus 7.1. Now I'm going to grab my calculator just to make sure I don't make any foolish mistakes here. So it's equal to the square root of, we're going to keep this 13.5, and then 13.5 minus 11.2 gives us 2.3. 13.5 minus 8.7 gives us 4.8, and 13.5 minus 7.1 gives us 6.4. So if I multiply 13.5 times 2.3 times 4.8 times 6.4, I get 953.856. Our area is going to be equal to the square root of that, which is 30.8845592489, etc. So 30.8845 ... So if that's our area, we're to the nearest 1/10 of a foot. So we can either take that, or you may determine, well, if the lengths are to the nearest 1/10 of a foot, if you were to multiply them together, you'd get to the nearest 100th. You could do that too. I wouldn't be that finicky about it, but since all of my lengths were in 1/10 of feet, I'm going to put this in tenths also, so 30.9. Remember, these are feet. We're talking about area, that's feet squared, or square feet. So the area of this particular triangle is 30.9 square feet. And that's it, using Heron's formula. So we find the semi-perimeter, which is just half of the perimeter, and then we subtract each of the sides from it, multiply those four things together, and take the square root, and we now have the area of a triangle based on only the lengths of the sides. And that's any triangle you can use that for. So there we go. Heron's formula, and that finishes up 8.2, the law of cosines.